Ride On Academia. We are still on our series on differentiation. Okay, now in this video I'm going to be showing us how we can differentiate using our chains rule, also called our functions of functions. Okay, in this case where alright, so in this case where our y, okay, our y is a function of an expression that has a power. Let's assume x raised to power 4 minus 5x raised to power 2, and then the entire expression is still raised to another power. Let's assume 3. Okay, this is what our functions of function is referring to when we want to differentiate our y. Okay, but our y is a function of an expression that is also raised to another power. Okay, now we've dropped videos on how to differentiate, like basically for beginners. We've dropped videos on how to differentiate using our product rule, using our quotient rule. So you have to, if you've not, check them out and then watch them so that you can follow us to where we are right now. Alright, so back to business. We want to see how to differentiate this using our u. In this case, since it's just one basic expression, we'll just be using only our u. Okay, so this bracket will just be our, this is our u, right? So we can be saying that y is equal to, if we are saying this can be, this is u, right? We can also say that y is equal to u raised to power 3. If this entire expression is equated to u, then we can also say that our y is equal to u raised to power 3. So what we do here is simply function of function. We differentiate our u, then multiply. Okay, so our rule that holds here for our functions of function, or our chains rule, is simply that when differentiating our y, okay, this y, our dy dx, we'll have to differentiate our u, alright, and then multiply it by our differentiated x. Alright, so we can say du dx because we're differentiating our u in respect to our x, alright, and then differentiating our y in respect to our u. So we multiply to get our former differentiation. Okay, now this is our u, like I said, this is our u. Okay, and this is our, I also said that our y can be this, right? Now let's solve quickly. We have that since I said this is our u, we can say that our y is equal to u raised to power 3, right? The first thing we're going to do is to differentiate our y with respect to u. That's why we are saying dy du. Alright, dy du means we are differentiating our y with respect to u. So we are going to be differentiating dy du. Alright, will be giving us what? 3u square. 3u square. Okay, we have done this. We are through. Now the next thing we need to do is to get our du dx. We are going to be differentiating our x. Like I said, our u can be equal to this. We have equated our u to be this. Alright, so we're going to be differentiating our u with respect to x. So we are differentiating at this point, right? So du dx with respect to this x, we'll be having what? On how to differentiate 4 times this, we'll be having 4x cubed because 4 minus 1, right? And then we'll be having 10x because of 2 minus 1. Okay, now we have done this. So the next thing to do is to impute into our value. Okay, we'll be inputting into our format dy dx to be equal to, now our du dx is this. This is 4x cubed minus 10x, right? And then to multiply by our dy du, which is this, we are having 3u square. Okay, to multiply by 3u square, let's use 3u square. This is it, to multiply by this. So in expanding our bracket or by substitution, what we do here is that we substitute for our u. Alright, so we still have to substitute for our u, and this is still our u. Alright, when we have entered in our formula, then we substitute for our u because our answer needs to be an expression of x. Okay, so we substitute for our u. We have our 4x cubed minus 10x. Alright, then multiply by, we'll be having 3. Our u is what? X raised to power 4 minus 5x squared. Alright, since it's our u squared, all raised to power 2. So this is how it's going to be looking like. And then we can bring in our 3 forward. Okay, we'll be having 3. Since it's multiplication, it still means the same thing. 4x cubed minus 10 multiplied by x raised to power 4 minus 5x squared all squared. So this is our final differentiated answer. So with this, we have come to the end of differentiating using our function to function format or formula or rule. If you've not liked our videos, if you've not been subscribing, if you've not been sharing our videos, please do so. Okay, we'll see you in our next class. Thank you.